On behalf of the entire team working on the publication Decentralized Multi-Agent Production Control through Economic Model Bidding for Matrix Production Systems, I would like to warmly welcome you to this presentation with the CIRPe2020 Global Web Conference. The CIRPe2020 Web Conference is focused around the main topic of flexible mass customization. Within this presentation, we will have a short look at matrix production systems, which are made to deal with such complexities. First of all, there is recent trends in demand towards a larger individualization at low cost and still requiring high quality from a customer perspective. This requires production systems to be both flexible and agile. On the other hand, there are recent technological trends that help us in enabling flexible mass customization. First of all, there is intelligent data acquisition, maybe QR or barcodes or any other form of intelligent acquiring the data necessary to enable production data analysis. With production data analysis, we are capable of improving our production system. Furthermore, there's a trend towards cyber-physical production systems which require both a cyber and physical version of the production system and allow us to further improve the production system at hand. And at the end of the line, there are agent-based production control systems which allow us to deal with the increased complexity within production control. Next, we would like to talk about matrix production systems. You can see a 2x2 matrix production system, or including two transparent sections, a 2x3 matrix production system, where all machines are individual machines and they are structured on the shop floor in the form of a matrix. You can see that the material flow is decoupled from machinery, and typically AGVs are used in order to facilitate transport of products and further required parts within the production system. There are quite a few advantages of having a matrix production system compared to traditional line production. First of all, it can adapt quickly to fluctuating demand in the sense of that you are able to retool and maintain several machines within the system without stopping the entire production system. Furthermore, it is much more simple to integrate products or variants if you can simply adapt few machines and you can have a living system that adapts towards your requirements of new products and different variants and types. Additionally, there is an increased robustness in case of disturbances, as there is no line production where one machine will stop and maintenance will stop all other machines affected within the line, but rather you have decoupled material flow and can shift the material flow around the current disturbance. Additionally, there's a high product lifecycle interdependence due to the adaptability in the sense of having several machines partially redundant, which are able to perform certain tasks and can be reused within the next production lifecycle. And last but not least, matrix production systems enable the flexible integration of remanufacturing activities in the sense of having material flow from one side to the other side, allowing assembly, deassembly, manufacturing, and remanufacturing. Furthermore, multi-agent systems are one way to deal with the complexity as introduced before. Instead of having a centralized control, we would rather have different agents acting and working within one system. As illustrated on this slide, you can see that machines and AGVs can serve as agents, and furthermore, all individual parts flowing to the production could also be modeled as agent. And this agent paradigm has several advantages in the sense of dividing the large problem of coordination in such a matrix production system into smaller sub-problems that can be solved individually, and an increased stability against unexpected and control system failures in the sense of that any failure will only affect a local situation and instead of a centralized failure that can affect the entire production system. Additionally, a centralized production system control is hardly adaptable to structural changes and requires a huge amount of time and work to be put in the production control system to deal with structural changes, whereas agent-based production control systems can easily adapt in the sense of you simply add or reduce the number of agents within the system. On the other hand, there are quite a few disadvantages to be considered. First of all, there's a potential gap towards the global optimum if you combine the sub-problem solutions from each agent's perspective. The coordination mechanism can also lead to deadlocks and problems within the production system that is controlled by agents. And last but not least, in case of using reinforcement learning agents or any other learning-based forms of agents, the learning can be both on a speed and on the learning effect can be hindered through the coordination mechanism. Last but not least, I would like to introduce reinforcement learning shortly. So reinforcement learning is based on the Markov decision process, where an agent is placed within an environment, and based on its perception of the environment called state, the agent selects an action that changes the course of the environment and also gives a reward towards the agent and allows the agent to optimize the reward by selecting optimal actions. In our research, we have implemented a multi-agent system where parts that would refer to the individual products, also transporters such as AGVs, and stations or machines are covered and modeled as an agent and can be both controlled by reinforcement learning or traditional priority rules. Let's have a look at the information flow. So whenever a part is placed inside the simulation or inside the shop floor, it provides information to its own control system about its targets and the situation around. Based on this, the control system selects a price and the process ID of the process that is desired to be followed next. Having that information, the information flows towards available transporters and towards the station in case the part or product is waiting in front of a station, whereas transporters and station evaluate these offers and evaluate prices, processes, and the advantage and disadvantage coming hand in hand with choosing either, and select one of the available parts. Once the control system of transporters and stations have evaluated, either of them changes the simulation by selecting the part and transporting or starting to working on the part. Let's look at the bidding process, which is the core of this coordination mechanism. So imagine we're looking at this matrix production system on the slide where we have a given source, several machines, and one AGV. Let's take the view of the AGV. There is a global exchange for transportation, which gathers all the process information, the locations and prices from each part within the productions, and allows the AGV agent to select the most suitable one. Based on the selection of the most suitable product or part, the AGV will target the station or the position the current product is located at, and will start transporting it to its desired station, which is also identified through the processes and the abilities of different stations and machines to perform certain tasks and processes. Let's have a look at the advantages of such a control and multi-agent based system control system. First of all, there is a modularity in the sense of that we have many different agent types, and each agent types can be changed without affecting the decision making of any other part. Concretely, that allows us to have the parts being controlled by reinforcement learning, whereas transporters and stations can still be controlled with priority rules or any other combination of these. Furthermore, the system presented allows for adaptability in the sense of changing the system and allowing the system to change over time in the sense of the number of agents can change, the types of agents, and further agents could be introduced as well. Combining reinforcement learning and priority rules allows us to take the best of both worlds. In other words, having stable priority rules which are easy to interpret, but also having the superiority and intelligent decision making of using reinforcement learning controlled agents. Additionally, having such an economic bidding model allows the communication to be simplified to only the few parameters of a price, bid, and the process ID, including further not necessary but potentially required information that helps in decision making but is not necessary to facilitate the production system to run easily. And last but not least, the decentralized production planning and control system allows the production system to change and to adapt towards different changes in the flexible mass customization framework, even when changing the system in the sense of exchanging stations, including new stations, or changing a structure, making a larger structural change to the matrix production system. Let's have a look at the results. In one of the cases, we can easily identify that parts being controlled by reinforcement learning agent, whereas the rest is controlled by priority rules, can lead to a lower waiting time and also to a higher and increased throughput of the system. We can see that the reinforcement learning part, the parts being controlled with reinforcement learning, and the product selecting their route individually, whereas the combination of stations and AGVs is controlled with shortest distance rule, performs significantly better than any other solution within the system. However, the system is required to focus on certain tasks. So whenever you would like to change the output of the system, which typically occurs in flexible mass customization, it is necessary to look at the cyber-physical system and reassure that the current choice of combination of decision-making rules is still adequate. All in all, our proposed economic decision bidding model allows the combination of reinforcement learning and priority rules for different types of production control agents, and by doing so allows our production system to be controlled efficiently. However, in the future, the verification in more and different diverse domains other than matrix production system is one way to increase the ability of our system to run and control production systems. Furthermore, at the moment, there is a huge competition between the different agents, as each of them would like to get the highest share of prices bid. But recent research in the field of computer science, where agents are working within a game, has shown that coordination can also lead to a quite good result. Thus, we would like to implement a more coordinated result and approach for our matrix production system control. And last but not least, changing the mechanism design could also implement structural changes and also provide even better results in the production control system. All in all, I would like to thank you for listening to this presentation, and I'm looking forward to your questions